In this lesson, we're going to talk about prisms and pyramids and their volumes. So to start with, let's see what are prisms. Prisms has two ends that are exactly the same size. So for example, if you look at this prism right here, triangular prism, this end is a triangle and the other base or the other end is also going to be a triangle with exactly the same size and shape. And a prism has two opposite ends that are parallel to each other. So these opposite ends will be also parallel to each other. So if you look at the square prism, you have one base here and the other base on the other side, which is exactly, these areas will be the same for both these ends. And they're parallel to each other. So what makes a prism different from a pyramid is if you take a prism and if you decide to bring one end together, all these three vertex together into one single point. So you took this base and you made it into a point. Instead of a parallel base, you brought it together as a single point, and this point is going to be called apex. So that's how a prism can be changed to a pyramid. If you change one of the bases into a point, bring it together to form a point, and you leave the other base just like that. So that becomes a triangular pyramid because the base is in the shape of a triangle. This is formed from this prism. Okay, from a square prism, you get a square pyramid by making one of the bases come together as one single vertex called the apex. And then the base is in the shape of a square, so you call it square pyramid. So the base is what decides what's the name of the pyramid or the prism. Alright, so here it's a pentagon, so you call it a pentagonal prism. Here the base is a pentagon, so you call this a pentagonal pyramid. So depending on the base, the prisms and pyramids are named. The prisms and pyramids are named after their bases. Also remember, from each prism you get the corresponding pyramid. So if you look here, the basic formula for volume of any shape, volume basic formula is always base area times height. Base area times height. So here, you look at this shape, this is a cylinder. So the volume is base area times height. So depending upon the shape of the base, this formula will change. Here the base is a circle. This is a circular base. Okay. So when I say base area, you're going to have to use the area of a circle, which is pi r squared times h. So this becomes the formula for volume of a cylinder. Now how do you make this shape? This is called a cone. A cone is made from a corresponding cylinder, and when you cut it out like that. Okay. So if I take a cylinder and I cut it, if I find the center of the circle of the base over here, if I find that center and I join it like that, like I bring this whole circle, I reduce it and bring it together to form one point there, that vertex. That's how you make a cone. So the volume of a cylinder and cone are connected, except that the cone will have less volume, if you think about it. So it's 1/3 base area times height. So it's the same formula as the formula of a cylinder, except you have the fraction 1/3 pi r squared h. Height being the straight height here, perpendicular height. This is the height. This is not called the height, that's called the slant height. The height is always straight, perpendicular to the base. Okay. So next we have volume for a prism. This is a prism. That's a cylinder. Volume is again base area times height. If it's a rectangular base, you would put the area of a rectangle here. Let's assume that this is a square. So two sides are equal, the length and the width. Let's just call it length, width, and then the height of the prism. This is where the formula volume is equal to length times width times height comes from. It comes from this general formula. Okay. So if it's a square, L and W will be the same. So it will just be the same number here that you're multiplying to get the base area. If this is a pentagon, you have to put the base area of a pentagon. So depending upon what's the shape of the base, you have to change the formula here. If this is a triangle, you will put the area of a triangle here instead of base area. So whatever is the shape of the base, it determines the formula that comes here. And the height is just the height of the prism, the height. Now, how does the volume of a prism compare with the volume of a corresponding pyramid? A pyramid is formed by cutting a prism, just like how a cone is formed by cutting a cylinder. So the volume formula is 1/3 base area times height, just like that. But the only difference is that the base is not a circle. Like in the cone, the base was a circle, so the base area was pi r squared. Here the base is, it's either a square sometimes, or a rectangle sometimes, or a triangle sometimes. It could be anything other than a circle. So let's say for an example sake, this is length times width. So this becomes 1/3 length times width times height. Now, how does the ratio of the length of the sides connect to the ratio of perimeter, area, and volume? So you have two similar triangles here. Triangle A similar to triangle B. Okay, so this is the ratio. This is the ratio of the side lengths. Okay, so 3:2. 3:2, or you can call this as 6:4. 6:4, which when you reduce it, you still get 3:2. Okay, so the formula is this. If you're trying to find the ratio of the perimeter, is the same as the ratio of the sides. So if you call the ratio of the sides as A to B, okay, the ratio of the perimeter will be the same as A to B. The ratio of the area will be A square to B square, and the ratio of the volume will be A cube to B cube. So there are three formulas. Remember, whenever you write perimeter, you use the unit as centimeter. That'll be centimeter squared. That'll be centimeter cube. So depending on the volume, depending on what you're trying to find out, the formula will change. So in this problem, the ratio of the side is 3:2. So the ratio of areas is 3 square is to 2 square. Here the ratio of the side is 3:15. So when you reduce it, it becomes 1:5. Or you can just take 1:5. So ratio of areas will be 1 square is to 5 square, which is 1:25. Next, here you have to find the ratio of the volumes. So here the ratio of the side here is 5:4. So the ratio of the volume is 5 cube is to 4 cube. 5 cube is 125. 4 cube is 64. So that's how you find the ratio of volumes and the ratio of areas.